Okay, so continue with our chapter, motion. Let's discuss today the 7, 10, and 14 on the tuition note question numbers. 7, let's start with that. What is a straight line motion? These are so easy that we can just look and write it down, okay? So motion of an object through or traveling through a straight line path is called a straight line motion. For example, a ball is rolling on a perfectly flat surface in a straight line that would constitute or make a straight line motion, right? Now think of something which is not straight line motion to get it clearer. Yes, the clock is moving in a circle. The hand of a clock, second hand, is moving in a circular fashion. That is not a straight line motion, that is a circular motion, right? So next, question number 10, which this is actually question number 3, textbook, page 107. So go to your tuition note, if you don't have, go to your textbook, page 107, question number 3. Okay, so let us do that. Question number 10. Which of the following is true for displacement? Remember displacement and give reason for your answer. This number A, it cannot be 0. That means displacement cannot be 0, the question is saying. Is that true? Let us see. Its magnitude is greater than the distance traveled by the object. Okay, I think this is quite easy. None of this is true because we know from question number 5 in your previous classes, if you turn your note, you'll find in the first case, B, let us start with B, which is saying magnitude is greater than the distance traveled. We know that this is not true because we know that in a given situation, displacement is always smaller, right? Or can be at the most equal to distance traveled in magnitude, but it cannot be greater. So that is false. Statement number B is false. Where will you find this? You'll find this. You can write down here below. In question number 5, tuition note. In your previous classes, we have discussed difference between distance and displacement. There we have seen this point, right? And the second point is A here. A. This is not C. A. Okay, sorry. A. Their question is saying displacement cannot be 0. But we'll learn in our previous classes that displacement can be 0 when and if the object has returned to its initial position, like Rocco swimming from here to this side 5 meters and then coming back to the starting point here, went to B and the C, his final position and initial position are same, then there is no gap between initial and final point, so shortest distance is displacement, so it is 0 na. So it can be 0. So this statement of the question that displacement cannot be 0 is not true, or rather false. Okay, so these are easy questions. Now 7 and 10 done. We'll go and do 14, which is a numerical. Okay, I hope you're getting it. Now question number 14. Go there, tuition note. This is also a textbook question. So on your textbook, this you'll find as example 8.1, I think. Yes, this is a textbook question on page numerical, okay, 108. This is the first numerical that we're doing. Okay, now listen to this carefully. Last class we have discussed certain things, right? Uniform and non-uniform speed, uniform and non-uniform motion and all. It will come into picture now. Let me read the question for us. An object travels 16 meters in 4 seconds. And then another 16 meters, same distance, but in different time, 2 seconds. So this is clearly the object is traveling like this. Let us do this. Let us find out. Let us read once more. What is the average speed of the object? So we have to find average speed because this body is not in uniform motion. In the first 4 seconds time, it covers 16 meters. And I cover another 16 meters from here to here, it means 32 now, in 2 seconds. So time is different, you see. So the object is traveling in non-uniform motion. So we learned in our previous class that, just the class before this, that for non-uniform motion, we calculate average speed, average speed and not speed. Speed is equal to distance. Speed is equal to distance by time is for uniform motion. But for non-uniform motion, average speed is equal to total distance traveled by total time taken. So we're going to use that formula for average speed here. So here, as we read the question, total, write along with me, distance, okay, total distance covered or traveled, whatever you like to put, traveled, let us say traveled is equal to 16 meter in the first 4 seconds and another 16 meter in the next second. So that is 32 meter total distance. Then total time taken, go back to the question, total time taken is equal to, in the first 4 seconds 16 meter, in the next 2 seconds 16 meter. So it is 4 seconds plus 2 seconds, which is 4 plus 2 is 6 seconds. Therefore, since it's in non-uniform motion, we have to calculate average speed. If it was in uniform motion, we would have directly said speed, right? Average speed is therefore total distance traveled, we know this formula in our previous class, divided by total time taken to travel that distance. So it's just a matter of applying the formula. Total distance is 32 meter. By time is 6 seconds. So here meter per second, because numerator meter, down second. So here 2 3s are 6, 2 1s are 2, 1 in hand, 2 6 are 12. So 16 by 3, we can write it as 3 5s are 15, 1 in hand. And we can stop there also. We write one way is quotient first, dash, remainder up, and divisor down. So 5 1 by 3 meter per second. Or if you want, you can put point and divide, up to you. Okay. So this average speed of this object is 5 1 by 3 meter per second. Slightly more than 5 seconds, 5 meter per second. Okay. Or you can also write here, in textbook you will find frequently like this also. That's up to you. So this concludes the video 5. Okay. This class will continue in the next class.